Today's lesson is how to apply the fundamental theorem of algebra. So your essential question is, how do I find all of the zeros, both real and imaginary, of a function? So we've been finding the real zeros of a function, but now we can figure out how many zeros a function has just by looking at the equation, and also how to find the real and the imaginary zeros. So a repeated solution is when a solution appears more than once. So if we look at this function, x cubed minus 5x squared minus 8x plus 48 equals 0, I can factor that down. I can use synthetic division to find one of the factors and then keep factoring it, or I can use the graphing calculator to find one, or a picture of the graph, but I did all that work for you. So this actually factors down into x plus 3 times x minus 4 times x minus 4. So you can see that x minus 4 is on there twice. So if I set that equal to 0, 4 is going to be a solution twice, and that's called a repeated solution. So sometimes your solutions will be repeated, so you'll think you'll have 5, but then you only have 3, and that might be because one of the solutions is repeated a couple of times. So what is the fundamental theorem of algebra? If a polynomial function has a degree greater than 0, then the number of solutions, or zeros, is equal to the degree. So going back to this equation up here, we had x to the third power as our highest exponent, so the degree is 3. That means it will have 3 solutions, whether they're real or imaginary. So if we were to set all of these equal to 0, then the solutions would be x equals negative 3 and x equals 4 would be on there twice. So technically it has 3 real solutions. Now it can have imaginary solutions with the variable I, or it can also be real, or it can be repeated. So those are your options for how many zeros a function can have. So if we look at this example, what is the degree of this function? Well, if I look at it, I have x to the 4th power is my highest exponent, so the degree would be 4. So it would have 4 solutions, and it can be both real and imaginary, or all imaginary or all real. We just have to find out. Now, we also have a couple other theorems that are important. We have the complex conjugates theorem and the irrational conjugates theorem. So what this says is that if a plus bi is a solution of a polynomial, or a 0, then a minus bi is also a solution. So if I had like 2 plus 3i was one of my solutions, then 2 minus 3i, the conjugate of that, the complex conjugate of that, would also be a solution, or a 0. Okay, and then I have the irrational conjugates theorem, which says that if I have a plus the square root of a number as a solution to a polynomial function, then a minus the square root of that number is also a solution. So if I had 6 plus the square root of 7i was a solution, then 6 minus the square root of 7i would also be a solution. Okay? So those are just a couple of theorems that you need to be aware of when you're finding all of the zeros. So we're going to take a look at a few examples. So what must also be a 0? Given the following number is a 0 of the function f of x, what other number must also be a 0? So if I have 5 plus the square root of 6 is one of my zeros, what must also be a 0? Well, that would be the conjugate of that, which would be 5 minus the square root of 6. Pretty easy. And if 3 minus I is a 0, then 3 plus I would also be a 0. All right, so let's get into the meat and potatoes. So finding all the zeros of a polynomial function. So we have this example. They want us to find all the zeros, both real and imaginary. So I'm going to do this the same way that I've been doing it with the previous sections. I'm going to find the first 0. So I can list out all the possibles if I want to. And I don't necessarily have to do that. But if I was going to list out the possible zeros, I would find factors of negative 16 the constant, and factors of 1. So they could be both positive or negative. So I would have 1, 4, and, oh, I forgot 2. 1, 2, 4, 8, and 16, and 1. So if I put all those numbers over 1, then these would be my possible real zeros, okay? So I could pick one of those and test it using synthetic division and figure out if it works. But we're going to use a shortcut. We're going to use our graphing calculator, and we're going to graph the function. Let's see if I can get it to turn on. There we go. So I've already entered this function into the graphing calculator, and I'm going to graph it. And it looks like this. So I need to pick one of the zeros that I see on the graph, and there are 2. There's -1 and +1. Now those are only our real zeros. And if you look at the degree, how many zeros is this function supposed to have? If we look, it's supposed to have 4 because the degree is 4. So that will only give us our real zeros. So I'm going to pick one of those. I'm going to pick -1 to use, and I'm going to do synthetic division. So I put -1 on the outside, then I have to put all the coefficients on the inside. Now I have 1x to the 4th, but I skipped x cubed, so I'm going to put a 0 there. 0x cubed, 15x squared. I skipped x, so I have to put another 0, and then -16. So I bring this one down, and then I multiply these numbers, so I get -1, and then I add, so I get -1, and then I multiply, and I get +1, and then I add, and I get 16, and then I multiply, and I get -16, and then I add, and I get -16. I multiply one more time, and I get 16, and when I add, I get a remainder of 0, because it should divide evenly since it's a factor. So this is what's left here, and so that would be x squared, or I'm sorry, x cubed, because this would be the constant, this would be the x, this would be the x squared, this would be x cubed. So x cubed minus x squared plus 16x minus 16. Now I need to factor this. There's only one possible way to factor this because there are 4 terms, and that is factoring by grouping. So I'm going to group the first 2 together and group the second 2 together, and I'm going to take out the greatest common factors. So the greatest common factor of this group would be x, and then I would have, or I'm sorry, x squared. Then I would have left over x minus 1. And then the greatest common factor of this group would be a positive 16. And I would have left over x minus 1. So my factors are x squared plus 16 and x minus 1. And I'm trying to find the zeros. And I already had the -1 that I used before, so technically x plus 1 is also a factor if I wanted to, if I wanted to leave that in there. So I would set all of these equal to 0 to get my zeros. So I would have x plus 1 is equal to 0, which I already know the answer to that is x equals -1 because that's the one that I started with if I was to subtract 1 from both sides. Then I have x squared plus 16 equals 0. So I would subtract 16 from both sides, and I would get x squared equals -16. And then I would have to take the square root. Well, what's the square root of a negative number? I can't really do that, but I can use the imaginary number I. So technically, x could be equal to positive or negative 4i. Because the square root of 16 is 4, and since it's negative, we have to use the imaginary number I. Then I have the last part, x minus 1 equals 0. So I would add 1 to both sides, and so I would get x equals 1. So I should have 1, 2, and then this counts as 2. I have positive 4i or negative 4i. So that gives me all 4 of my zeros, both imaginary and real. All right, last thing. Using the zeros to write a polynomial function. It says write a polynomial function of least degree that has the given zeros. And actually, this also should say that it has a coefficient of 1, because we don't know necessarily if it has a different coefficient, but we can make sure that it has a coefficient of 1, and I'll kind of explain that again in a minute. So if these are my zeros, negative 1, 2, and 4, then what are my factors? So remember, if that means that if I set my factor equal to 0, I get these three numbers as my answers. So I'm going to write f of x because we're writing a polynomial function. Okay, and negative 1 is my 0, so that means x plus 1 is my factor, because the 0 and the factor are always opposite of each other, because if I was to set x plus 1 equal to 0, I would get negative 1 as my answer. And then x minus 2 would be my other factor, and x minus 4 would be my other factor. Now technically, this is a function, but I want to actually simplify it and work it all the way out. So I need to multiply these three binomials together. So I'm going to double distribute these first two. And so I would get x squared. X times x is x squared. X times negative 2 would be negative 2x. 1 times x would be x. And 1 times negative 2 would be negative 2. And then I can combine these together. So I would get x squared minus x minus 2. And then I still have to multiply that by x minus 4. So now I'm going to distribute these. So I have to take x squared times both terms, which would give me x squared times x would be x cubed. X squared times negative 4 would be negative 4x squared. And then I would take negative x times both numbers. So negative x times x would be negative x squared. Negative x times negative 4 would be positive 4x. And then negative 2 times both numbers. So we have negative 2 times x is negative 2x. And negative 2 times negative 4 is positive 8. Then the last thing I can do is combine my like terms. So if I put these together, I get x cubed minus 5x squared. And then I can put these together, so plus 2x plus 8. So this is my polynomial function of least degree, so it has the smallest degree possible, 3, that has these three numbers as zeros and a leading coefficient of 1. So it's because I could put like a 2 or any other number here that I wanted, but I really don't know what it is, so I'm saying that it has a leading coefficient of 1. So that's what I meant by that earlier. All right, so you guys can go ahead and go back to your essential question and write your summary. Thank you.